Okay, good morning Akshita. In our previous class, we stopped at the sixth problem. Now we are proceeding ahead. Say the seventh problem. Which of the following is rational? He is not talking about irrational, rational. If you see here carefully, root 3 is irrational. I am classifying all the options into two categories, rational, irrational. So first option, root 3 is irrational because 3 is not a perfect square. Next, coming to the third option, 4 by 0. It is not irrational also. 4 by 0 is like undefined. We cannot call it rational or we cannot call it irrational. So we don't put it in any of the classification, or you can say third classification. Next comes 0 by 4. 0 by 4 is 0. Therefore, it is rational. Answer is option D. Now, what about option B, Bombay? Pi is there, na? Pi is called famous irrational number. Its value is 3.14. If you want to see it properly, I can show you on the screen. Is there pi over here? No, there is no pi. I will show it. 1 second, just give me time. Yeah, this is the pi value. 3.1415926535897932. Anywhere repeating? Anyway, sir, since there is an end for the calculator, it is showing the end digit. Otherwise, it will go on. It will go on like that. And there is no repetition anywhere. Pi is a famous irrational number. So, answer is option D, 0 by 4. Now, going to the 8th question. See, the number 0.318564 56431856431. So if you see carefully, Akshita, in examination, in tension, you might put this as irrational number because no repetition and it is not ending. So we might put answer as an irrational number, but this is absolutely wrong. This is not a natural number. Pakka, we can say this. It is not an integer. Pakka, because there is a decimal number which is repeating decimal. No, not repeating. Like non-ending. So it cannot be integer. It cannot be natural number. So it is a rational number. If you see carefully, 318564. Next. 318564. So same thing can be written as 318564 bar. This is repeating and non-terminating decimal. Repeating and non-terminating decimal. So this is going to be our rational number. Therefore, answer is option C. In by mistake, in hurry and everything, we can put answer as irrational, but that's wrong. You have to see very carefully. Next, coming to the question number 9. If n is natural number, then root n is. Is it always a natural number? No. So root 10, he is asking n is a natural number. If you just take the first 10 natural numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Root 1, root 2, root 3, root 4, root 5, root 6, root 7, root 8, root 9, root 10. Correct? So first of all, root 1 answer is 1. Root 4 answer is 2. Root 9 answer is 3. Yes, for 3 natural numbers, their roots are natural numbers, accepted. But what about remaining root 2, root 3, root 5, root 6, root 7, root 8, root 10? They are all irrational numbers. So answer is going to be here sometimes natural, sometimes an irrational number. Clear? Next question. Which of the following numbers can be represented as non-terminating and repeating decimals? Very important question. Non-terminating but repeating. When will you have repeating? Sir, see carefully. When you have any fraction, you will have numerator and denominator. Correct? So, in this denominator is something which decides whether the fraction is repeating or terminating. Sorry, I'm just got yawning. So this denominator is what which decides whether the fraction is repeating or non-repeating. Now, when you talk about the denominator, in denominator you can have all the numbers like 1, 2, 3 up to 10. Now you might be thinking, sir, why only 10, why not 11, 12, or infinite can be there, na? But everything you can do prime factorization and bring back to, you know, sir, any number can be prime factorized. You know, I think prime factorization, any number can be prime factorized. So what are prime numbers? You have 2, 5, 7, 11, 13 and so on. Among all the prime numbers, only 2 is even number. That's it. Now something very important I wanted to say, if in place of denominator, if either 2 or either 5 or multiples of 2, 5 or both, if these things are there, that fraction is going to be terminating. It will not be repeating for a long time, and after some time actually with some decimal digits it will stop. For example, 1 by 2, 2 is there, 0.5, 1 by 5, 0.2, 1 by 10, 10 is nothing but 2 into 5, 0.1, it stopped. Only 2 and 5 should be there, then only that fraction will become terminating. It will stop after some time. If other than 2 and 5, any other number 3, 5, 3, 7, 11, 13, anything is there, surely it is not going to stop. It is going to be a repeating decimal. If you see all these fractions, so the following numbers. So if you see carefully, Akshita, here 39 by 24. Okay, let me erase all these things on the board. No. The first one, that is 39 by 24. In 3 table you can cancel 3 into 13, 3 into 8. Sir, 8 is purely a multiple of 2. Therefore, this is going to be a terminating decimal. It will stop after some time. If you want, you know, I can show you on calculator or by doing also. 8 divided by 13. 8 ones are 8. 5.0. 8 6 are 48. 2 again 0, 8 2s are 16, 4 0, 8 5s are 40. Kam khatam, dukan band. So this fraction is 1.625. That's why I called it as a terminating. Next, coming to 3 by 16. Again 16 is purely a 2 power. Therefore, this is also going to be a terminating decimal. I wanted to show it. 3 divided by 16. 0.1875 terminated. Therefore, this is also terminating. Now, if you talk about 3 by 11, in denominator there is no 2, there is no 5. Now 11 is there. Other than 2 and 5, anything else extra is there, it is going to become a repeating decimal. 3 by 11 is going to be non-terminating. Matlab, it is going to be repeating. Clear? Next, 137 by 25. 25 is purely a multiple of 5. Therefore, this is also going to be terminating. You wanted to see how much it terminates exactly. 137 divided by 25. 5.48. I think it's very clear. Whenever 2 multiple or 3 or 5 multiple or combination multiple is there, it is going to be, you know, non-terminating. Otherwise, it is always going to repeat. Clear? This question is something highly important. Next, there are questions which we have to paste. Just take a small break. Okay. Okay, let's continue. Now, question number 11. Every point on a number line represents a unique real number, a natural number, a rational number, and irrational number. See, you right now you might not be knowing what is a real number or something, but remaining three options are known to us, so we can discuss them. If at all the remaining three options are not correct, then option A will be automatically correct. So every point on number line, does it represent a natural number? No, they can be 2.2, they can be 3.3, they can be 4.4, which are not natural numbers, but they can be on the number line. Therefore, option B is wrong. Next, every point on a number line represents rational number. Oh, absolute wrong actually. No sir, I have shown you how to represent root 2 on the number line. I have asked you how to represent root 10 on number line. That means root 2, root 3, root 4, root 2, root 3, root 5, root 6, which are irrational, they are present on the number line. Therefore, it is wrong that every number or every point in number line is a rational number is a wrong statement, and every point on number line represents irrational is also wrong. There are rational numbers, there are irrational numbers. They're friends, they stay together, they live together. Now, the family of rational numbers, the family of rational numbers and irrational numbers is called real numbers. Therefore, the answer is going to be a unique real number. Is that clear, Akshita? Going for the 12th question. Please see 12th question. Which of the following is irrational? See, 0.15 is terminating. No, it's not irrational. 0.01516, it is terminating. No, it is not rational. It is not irrational. 0.1516 repeated bar. Sir, it is non-terminating but repeating only, na? So therefore it is going to be rational. So this is also not irrational. The one and only one irrational number is option D. Is that clear, Akshita? Now I am going ahead. The number 1.27 bar in the P by Q form they want. So for this I have told you already the method. So you have to take X as 1.27, 27, 27, 27, so on. And then you will multiply this with 100. You already know why I am multiplying. Then this is going to be 127.27, 27, 27, 27. Now what we are going to do is we are going to subtract both of them. Then 99x is equal to 127 minus 1, that is 126.0000. Therefore x equal to 126 by 99. Right? So 126 by 99, what we have to do? Might be 9 table it goes. See carefully. 9 11s, 9 14s. Therefore the answer is going to be 14 by 11. Option B. Is that clear, Akshita? 14 by 11. So 1.27 bar can be written as 14 by 11. Next, question number 15. We are seeing the question number 15. 0.32 bar. Just bar is there only for 2. How to express it in the P by Q form? So take x equal to 0.3, 2, 2, 2, 2, 2, so on. Now, what we need is multiply with the 10. Then 10x is going to become 3.2222. Now multiply with another 10. Then 10 into 10x will become 100x. It is going to become 32.2222 and so on. So now I will erase the bottom part. Then why I erased the bottom part? Easily to understand. When you subtract, you will get 90x equal to 32 minus 3. That's going to be 29. Therefore, x equal to 29 divided by 90. That is nothing but option B. Clear now? Very, very simple thing. So now I will paste the remaining questions. Okay, Akshita, fine. Now let's go to the 17th question. Akshita, you might be seeing after 15th question why I am going for 17th question. What is the problem is 16. Some questions are not printed properly. I will open my textbook and I will give you the questions finally. Now whatever is available for us to put it on screen, I have put it. See this question, 0.001 bar when expressed in P by Q form, what it is, right? So x is equal to 0.001, 001, 001 and so on, right? Now I wanted to multiply it with 1000 x equal to, this point will go 3 places ahead, then it will become 1.001, 001, 001 and so on. Now when we subtract, we will get 999, x is equal to 1, x equal to 1 divided by 999. Therefore answer is going to be option D. Any doubt, Akshita? Please express your doubts through WhatsApp. I don't think, see, some of the things you are not understanding out of your laziness, Akshita, you are not asking me the doubts at all. If you are truly not understanding, sincere in the class, you have to ask the doubts. Without getting doubt, I don't understand how you are understanding the YouTube classes. Okay, x equal to 1 by 999. Clear? Now, going ahead, question number 19. An irrational number between 2 and 2.5. Okay. So, in the previous classes also I told you, find an irrational number between 2 and 3. Then what we have done, 2 can be written as root 4, 3 can be written as root 9. Therefore, root 5, root 6, root 7, root 8, these are all irrational numbers between 2 and 3 only. These will lie exactly in between. So, similar way, we are going to use this one also. 2 square is 4, therefore root 4. 2.5 into 2.5, if we do it in calculator, you will be getting it as 6.25. Therefore, between root 4 and root 6.5, they want an irrational number. Will root 11 be there in between 4 and 6.5? Wrong. Yes, root 5 will be there. Pakka. Root 12.5? No. Root 22.5? No. Therefore, the in between number is going to be root 5. And root 5 is the irrational number between 2 and 2.5. Is that clear? This is how we find the irrational number between two numbers. Now, going ahead. Question number 20. Number of consecutive zeros in 2 cube, 3 power 4, 5 power 4 into 7. Number of consecutive zeros. Means what is the meaning of consecutive zero, At the end of the number, you will be getting zeros, right? That's what. Like for 100, 2 consecutive zeros. For 1000, 3 consecutive zeros. For 10,000, 4 consecutive zeros. So like that, at the end of this number, how many consecutive zeros are going to come? Very simple, we can use calculator and do the question, right now? That is called foolishness, we should not use, but still, I will show you. So 2 cube means 8 into 3 power 4, 243. Next 5 power 4, 625 into 7. How many zeros came? See, this is the answer for that. 8505000. Now, this kind of question, I will answer it in less than 2-3 seconds. I will directly put answer as 3. That's it. Not because answer is available here, Akshita. No, there is another easier way. See here carefully. When can you get a 0? When you multiply 2 into 5, this is the only possibility you can get 1 0. 1 10 will be coming, right? Therefore, if 1 2 and 1 5 is there, you can get 10. No other possibility, no other possibility, no other possibility. 2 5's multiplication cannot give you 10. 2 2's multiplication cannot give you 0. So, only 1 2, 1 5. So, how many 2's are there here? We have 3 2's. How many 5's are there? 4 5's are there. But surely we need equal number of 2's and equal number of 5's to give the zeros. Therefore, 3 2's matlab 3 2's will combine with 3 5's to give you 3 zeros. This is the logic behind this question. Very beautiful question. So now Let me see, recording is happening properly. Yes, Akshita, with this we completed the irrational numbers. Some 3 questions are there which I am going to give you as homework. Thank you and bye bye. After this I am going to do the R.D. Sharma practice problems on your 8th class topics, because I recently bought the 8th class R.D. Sharma textbook. From now I am going to do the practice questions on your school topics from the R.D. Sharma. Thank you, bye bye.